In this video, we're going to have a look at using implicit differentiation. So just before we start, I want to show you guys a little trick. If you're differentiating something like, let's say y cubed with respect to x, though not with respect to y, all you do is you differentiate y cubed as you would normally, so you get 3y squared, and then you just multiply onto it dy dx. That's the simplest way to think about implicit differentiation. I don't want to confuse you with the whole chain rule and everything, because I know a lot of students do get confused with that. But if you would like me to explain that, just let me know in the comments and I can. Step number 1 in implicit differentiation is you want to differentiate each individual term. So the differential of sine x is cos x, but because there's a 2 multiplied onto it, it will be 2 cos x that it differentiates into. 2 cos y, well, first of all, cos y differentiates to minus sine y. Again, multiplying the 2 onto it will make it minus 2 sine y when you differentiate it. But like I said, when you're differentiating any y terms with respect to x, you not only differentiate it normally, like I did, you multiply onto it dy dx. And that's equal to the differential of the right hand side. Do remember to differentiate the right hand side too. I know a lot of students forget that. Now when you differentiate any constant, it's just equal to 0. Step number 2 is you make dy dx the subject of that formula. In this case, it's easiest if you add 2 sine y dy dx to both sides. So sorry, that's... Oh wait, no, we're still on part A. So 2 sine y dy dx, when you add it to the right hand side, or both sides, sorry, is equal to 2 cos x. I've just swapped over sides, by the way, just because I wanted the dy dx to be on the left hand side. To get that alone now, you need to get rid of the 2 sine y that's multiplied onto it by dividing 2 sine y from both sides. In this case, that's equal to 2 cos x all over 2 sine y. And that's the expression for... No, it isn't actually, because 2 over 2 cancels out. So just cos x over sine y is your final expression for dy dx. Okay, let's now move on to the next part of this question, which is very commonly asked in differentiation questions in year 2 maths. Find the coordinates where dy dx equal to 0. So what's commonly asked? We're just taking dy dx and making it equal to 0, right? Well, let's think about this. When is a fraction equal to 0? Can we divide by 0? We can't, can we? You can't divide a pizza between 0 people. So it's undefined. It doesn't exist. That means that a fraction can only equal 0 if the numerator of the fraction itself equals 0. Because 0 divided by anything, that on the other hand is always equal to 0. 0 divided by 1, 0 divided by 2, except 0 divided by 0, because like I mentioned, you can't divide by 0. So we say that this expression is only true when the numerator itself, cos x, is equal to 0. So if we solve this, we basically solve this. And it asks for x values between 0 and pi. When you do the inverse cos of 0, well, just a reminder of the cos curve, by the way, it would cross here at pi would be here. It equals 0 at exactly 1 point in this whole interval, which is when x itself is equal to 0. So that's your x coordinate of the point where dy dx is equal to 0. To find the y coordinate, now that you've got that x coordinate, let's have a little think about it. So cos x we know is equal to 0, but we want to find the value of sine... Sorry, I've had a bit of a mind blank. So we found the x coordinate where dy dx equals 0. We now need to find the y coordinate. What we can do is we know the expression of the whole curve, so we can put x equals 0 into that. 2 sine 0 is equal to, let's see, it's equal to 0, plus 2 cos y is equal to 3. But that wouldn't quite make sense, would it? Okay, on the other hand... Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excellineducation.co.uk.